Hey, welcome back. Good to see you all again. Thanks for joining the channel. Hope you're all well. This is finally happening. So after sitting here for about a month, this arrived back in January. Oh, I don't remember the date, but now it's February 16th. And I wanted to clear my bench off of a lot of other work before I started this one. But this one was sent to me by Angelo from California, and he wants it worked on. We talked together on the emails, struck a deal what we could do for it. He had a lot of disappointing experiences with repair shops, and he approached me with a plea to take his deck and give it a going over, and I agreed. Typically I don't take outside work from people that have to mail it in, ship it in, because of the risk of damage and the costs involved in shipping items back and forth, and the long wait times. But I listened to his story and I felt bad for him, because yeah, he was given I don't know, say a raw deal, but the service repair places that you take things to, they have to operate on a profit business. They can't just do willy-nilly work and work at a loss. They have to make a profit, and a machine like this, being as complicated as it is, considering its age, components are aging, a lot of things will need to be replaced, a lot of things could fail unexpectedly. Parts availability is another huge issue for some of these shops, so a lot of them won't touch this kind of work, and I don't really blame them, because they are in for a profit, right? But I agreed to take this on for Angelo, and he diligently shipped it to me, and thankfully it arrived. Minimal damage. There's a little bit of this top back corner here is dented in a little bit. It looks like it took maybe a hit, but everything else looks fine. And if you saw the condition of the box when it arrived at my door, you'd be surprised at the condition of this right now, because it was the box was smashed, and I had the UPS guy standing there waiting while I unwrapped it and inspected it, just to make sure that it wasn't damaged in any way. But it appears all good on the outside, which is the main thing. We can fix this stuff on the inside, right? So he wants me to go completely over this, give it a complete lube, a full recap, whatever it takes. He wants this to be in top working condition. He's had it since brand new, and he's taken very nice care of it. I can see here it's very clean. It's no wear. I don't see anything negative to say about the condition of it. It's very good condition, very nice. It's well cared for. And he left me a note. Let me read it to you. There's only one issue with the deck that I'm aware of right now, and that is the motor speed. I noticed after playing all the way through a 1200 foot long tape from left to right, when the tape reversed itself and started playing from right to left, there were times when the tape speed slowed down, or fluctuated between slow and normal sounding speed, as it was playing in the reverse direction. Also, I am aware that when either fast forward or rewind is engaged, the speed of the take-up reel that is being loaded starts off just fine, but it will slow down and almost stop spinning when it comes to about 80% loaded. This seems to happen when rewinding in either direction. Whichever motor is driving the take-up reel seems to be getting overloaded. And he included a brand new tape for my testing purposes. He wants that returned, which is no problem. I can get that back to him. I do have tapes here. I actually went out this last summer and bought a bunch of tapes at a yard sale, or it was actually a church rummage sale, but we can do that. So have a good idea of what he wants fixed. Let me go through and confirm the faults. I'll load it up with tape, and I'll play it through its paces, and I'll see what it does or doesn't do. I won't have any of that on camera, but I'll come back and report what I find, and we'll see. We'll use that as a starting point, and then from there we'll just take it apart and start going through everything. Alright, so stay tuned. Alright, so I spooled up this tape. This is a realistic super tape, 3600 foot. And I fast forward it. I played it on both sides, auto reverse. I fast forwarded it to the end, and yes, it does slow down when it gets towards the end of the tape. Seems like it runs out of torque. And doing the same thing in reverse, when it rewound, it does run out of torque at the end of the tape as it's getting close to the end. There's another problem going on here. I'll show you in a bit. You can see this thread hanging here. This is actually, look at this. I don't know, there's something on the head that's shredding the tape. And this little ball of fuzz is just created from me fast forwarding, rewinding. So that's kind of concerning. And looks like it's just made up of magnetic particles from the tape oxide coating. So something's going on with this head here that's shredding the tape. Maybe it's dirty. It is dirty. The roller's dirty. The capston's dirty. The impedance roller's dirty. This lever here seems bent because it is actually pushing the tape on this post. It's pushing it in, and I think this lever is bent in. This is the auto shut off. Now have a listen to this. I'll put it on. We're listening to tape right now, so let's turn the volume up. Put this on pause. Actually, here, let me thread this up again because it needs to be in play position. There's a lot of drag on these. Maybe it's the brakes or the clutches are not right. Okay, so let's put this in pause, press play. And if you can hear this rushing noise. Shouldn't be making that much noise when the tape's at a standstill. Scratchy pot a little bit. So we're getting a lot of noise, hiss and noise and rushing noise, but there's no hum. So that tells me it's not externally induced, this noise. I think it's coming within the amplifiers themselves. You can hear there's quite a bit. And that would be about the level that I would play back a tape at, right at the 12 o'clock position here. Okay, so let's have a listen to something else. I'm going to feed it a source. Here's the right channel. This is the microphone input. Seems to have a lot of issues. Some DC on that pot. Here's the line input. A little bit of scratchiness. But we still have all that hiss and noise from the transistors. Left channel. Microphone. There's obviously something wrong there. Got a bad transistor in that left microphone amplifier. Here's the line input. I got nothing coming from the line. This one's got DC and this one has bad transistor noise. So fix for that is replace transistors or capacitors. This noise is concerning though. It shouldn't be making this noise on the tape monitor side. And that's independent of the inputs. So that's good though. We'll use this as our reference from when we're done, and we'll hear if these noises are still present. Just want to look at this head. Why is it shredding the tape? Okay, I don't know if you can see this curl in the tape here. It's right here on this post. It's curling up here, and where else? And back here, oh, you can't see it. Back here, between this post and this post, there's an alignment issue between these two, and that's yeah, it's causing the tape to curl up here in these corners. So play, let's try play again. So it seems to play fine. I don't know if the heads are aligned properly or not. I'm not getting full fidelity on these tapes, but then I don't know where these tapes have been recorded and what's on them or how old they are or anything like that. So I can't use them as a judgment. But when I fast forward, see, we get that curling up here. Curls up pretty badly on something. There it goes. He's jumping around the tape. I don't know what it was doing there. And it is lacking in torque. Let me try rewinding. Seems to take a while to get up to speed. The motors are low in torque. I'm just wondering if maybe that's a weak capacitor. A weak field capacitor. So let's see how this goes here. It doesn't seem to be shredding the tape this time because I have it laying on its back. Just going to wait for it to finish here. I'm not seeing the shredding going on. It is slowing down. Yeah, getting slower. That could be a symptom of the motors. The lubrication in the motors is getting old and sticky and dried up, and causing drag in the bearings. That could be another thing. But it seems like usually when you get to that point, bearings are getting sticky with old grease. They start making really a lot of noise. Usually they howl or squeal or something. But these are quiet. So yeah, it's getting slower. It's having troubles. And here we go. Getting close to the end. Quite a bit of curl here. Okay, let's have a look at some of the components here. We have the capstan and the pinch roller. It's dirty. Let's go across here. Look at the first head, playback head. It's a glass head. Looks okay. I can't really tell much through the viewfinder or without a good inspection of the lens, or with a good lens. Here's the erase heads. One on the right there looks kind of dirty. There's the posts. They're dirty. A little bit of wear on this post. And here is the last head. The head on the left. This one looks... they look clean, and they don't look worn. They're glass heads, so should be no troubles with these heads. But we'll have a see. Now I did look at the adjustment screws, and it looks like nobody has adjusted anything on any of these heads. They're all factory set. So my goal is to just not touch those and leave it factory set, because I do not have an alignment tape at this point. Alright, so here's the first look with the cover off, and this is kind of typical of these old things. Look at this, it's so fragile, it's just dust. It just crumbles. It used to be a foam, open cell foam, but now it just crumbles into a dust. So I got to remove all this and replace it with something modern. Anyways, enough of that. Pretty easy to get to all the mechanicals here. Everything's open and accessible. Should be no problem. Main solenoid. This one here engages the capstan onto the roller. That's the main one, I think. And this one here is your brakes. Everything looks good. Looks like it just needs a lubrication. Where is that? This is the switches all over. Yeah, it's typical. This switch here is the speed switch. That's the one I suspect might be causing him having speed issues. Usually when these switches get dirty and old, they lose contact, and then the servo kind of goes crazy. So here's a switch back here. That's part of it. This might go to the servo. So I can check the contact resistance on these switches and make sure it's not the problem. Everything looks good. I'll just continue opening this up. Okay, now we got it out of the box. We can see a little bit more of the chassis. There's the main power transformer in the center. And we have 2 direct drive motors for the reels. Take up and supply. Got a couple fuse boards here. There's 3 fuses on this side, 3 fuses on this side. I don't know why they put them backwards so you can't see the fuses. It kind of doesn't make sense. I think we have what's a power supply on this side here. The little, let me see here. Yeah, it might be either that or it's a servo. We have a power transistor up here, which is a voltage regulator for the unit. Our main capstan motor under here. Quite a few little electronic boards everywhere. It looks like it's been cut and spliced. I don't know what that's all about. I think maybe somebody cut that and spliced it. I don't know. Quite a bit going on here. There's little circuit boards everywhere. Input output down here. What's this here? This board here could be power supply or servo, I'm not sure. There's another cap hiding underneath here. Another electrolytic. This is probably for the Capstone Motor. And if we look down, we have the electronics section. It's all on the bottom, and it's separated. This connector. Nothing's plugged in right now, so I'm good to touch things. Play with that later. Gold connectors. It's nice to see. A lot of dust going on down here, and this is all the amplifier boards at the bottom. So I think what I'm going to do first is I'll just take out the amplifiers and the electronics, and we will start doing the recap and retransistoring any of the 2SC 485s or the 458s. I can't remember. Let me check my list. 2SC 458s. Yeah, there's quite a few of them in here, and those are problematic, and they're probably the cause of a lot of the noise that's going on in the amplifiers right now. That, and along with old capacitors. So we'll deal with that right now. So I'll take out the chassis, the electronics chassis, and we'll put the mechanical aside for the moment, and then we'll start work. Alright, so I got the amplifier block out, the electronics block, whatever they call it, and it comes out as a unit. You remove 3 connectors, 1, 2, and then 3, and then you remove 3 screws on each side, and this thing just drops right out. It's pretty easy. So let's have a look here inside. It's kind of dusty. I might take it outside and blow the dust off it, but it's minus 15 Celsius right now, so it's not a pleasant day. It's a good day to be inside fixing Akais. Okay, so like I said, I had DC on this pot, so I'm going to have to check these capacitors here that are related to this potentiometer. I have a feeling some of them are really leaky or shorted even, and yeah, I'm just going to replace all these because there's no point in trying to go through and evaluate which one's good, which one's bad. Just do them all, blanket recapping. That's what the owner asked for anyway, so that's what I'll do. Transistors, I'm looking at transistors here, and I'm also seeing, yeah, the silver whiskers, the silver, you can see it here, the silver migration on these transistor legs, the black tarnish that wipes off. These are C458s. These aren't the same package as the ones I typically encounter, but we'll replace these anyway. Yeah, we'll go through and replace them, and then we'll try the amplifiers out and see how they sound. A lot of dust though. I'm going to go blow this dust out, and then I'll get back. So for right now, start recapping and take the bottom off. Start recapping and replacing transistors. And then we'll evaluate if we find anything else wrong. We'll do that work as well. Let's have a look at the bottom. That looks pretty good. I'll go through and check all these joints. I don't see any crack solders. And there really shouldn't be any crack solders on this kind of a circuit because there's really no heat buildup. Everything. Oh, just look at this. This might be shipping damage here. It's broken here. We'll have to address that. That's broken. Got a trace that's broken. Two traces broken. Yeah, so maybe that's from shipping. I'm not sure. It's hard to say. Okay, but this is definitely microphone input here, line input. So I'm assuming this is playback here, and this is the input side, so this would be the recording side. Yeah. Well, we had noisy transistors in both, so we're going to have to deal with that. And we'll clean pots and switches while we're in here too. Alright, so I'm starting to do recap on the machine, and there's some caps on the chassis. I'll point them out to you here. There's this one here, C6. It is a 3.5. Oh, you can't see it, can you? Go down a little bit. It's a 3.5 microfarad and a 1.5 microfarad in the same can. And I don't think it's electrolytic. I think it's like a paper capacitor. It's not polarized. It is 150 volts AC working voltage. And this is for the Capstone Motor. Right here is Capstone Motor. And the induction motor, it's got one main winding, and then it's got a shade winding. That's a capacitor. It's got a capacitor circuit. And this capacitor tests fine. If it's in the 60 Hertz position, it should only be the 3.5, and this 1.5 should be out of the equation. I'm looking at these caps here, C3. Now, if I go to the parts list, let me show you here. This is C3. It's classified as an MP capacitor. I don't know what MP stands for. It's got MP written on the can too. Multi-layer paper, I don't know what it means. And it says 3+1, but on the can it's clearly marked as 3 microfarad, and there's two of them in there, and they're both rated at 250 volts working AC. So that's the one I want to check, because I have a feeling that's, if I go back here, I have a feeling this capacitor C3 is responsible for the torque of these two motors. That's why I think it's probably weak, and maybe that's why the supply motor, that take-up motor, are not working their best. Each motor has its own capacitor, but yeah, I just want to get in there and check these caps, so I'll do that next. Alright, a little update here. I got this is the servo circuit for the Capstone. This has all been recapped and checked over and cleaned. Everything's good here. So that can be reinstalled. Put that back. Do that after. This board here is the power supply, and I recapped this one as well. I removed the relay. I can't really see it here. I don't have a lot of cabling to move here. I removed the relay and I checked the contacts just because maybe they were pitted or not. I opened it up and cleaned them. The contacts are in good condition, so I cleaned them, non-abrasive, and I put it all back together. So that's good. There's two capacitors I removed here, and these are 0.47 microfarad, 250 volts. These are marked MP as well. I think they're kind of a non-polarized electrolytic. I'm not really sure. This one's got a date code 1977 of December, Hitachi branded. Same thing with this. This is another capacitor. It's marked MP. This is a 3 + 3 microfarad, and this one's date coded 1978. And let me show you what I found with these two capacitors when I connect them to my meter. These two capacitors here, let me show you on the paper. I think that might be a little easier to explain. Hopefully you can see this. Hopefully you can see this. These two small capacitors, C1 and C2, that's these ones here, C1 and C2, and they go across the line. See these two, this line here and this line here, this is the power for this is supply and take-up motors. And these capacitors are snubbers. They snub any high voltage spiking that's coming from these switches and these coils. So that's what they're there for. I tested one of them, it's completely open circuit, and the other one's fine. But I think I'm going to replace them anyway. These capacitor here, C3, it doesn't show a value here, but this is capacitor C3. It's a double capacitor, and it's 3 microfarad each. And let me hook this up to the tester. I'll show you what it shows. Okay, so this first one is going to be the 0.47 microfarad. This is C1 or C2. I'm not sure which one it is. Connect this up, and this one comes back at 650 nanofarads, which is a lot higher than its rating. It should be 470. And an ESR of 66, 67 ohms, which isn't that great. Now here's the other capacitor. Remember, these are just snubbers. So this one checks out at 15 picofarads, and it's got 12 or 13 megohms, so it's open. This capacitor is open inside. Now let's check the 3 microfarad capacitor. I'm going to connect up one side here, and it reads 3.5 microfarads and about 3.8, 3.7 ohm ESR. Okay, the other side is 3.2, a little slightly less, and it's got a 2.9 ohm ESR. Now this is what I plan to replace the 3 microfarad capacitor with. This is a 3.3 microfarad film capacitor, and we'll have a look at this. This is a 3.3 microfarad at 10%, 500 working volts DC. This is a dry film capacitor, and we can see the microfarads is bang on at 3.36. It's within 10% easily. And look at the ESR on this. It's around 70 milliohms, which is more to my liking, rather than having a higher ESR like that. Let's try the other one I'm going to intend to replace it with. Here's another one, 3.28 microfarads, same thing, and this one's around 100 milliohms, somewhere around there. So yeah, it's my intention to remove this capacitor, because I think this one is what the is causing the issue with the lack of torque on the supply and take-up reel motors. And I'm going to replace it with these two film capacitors. And I intend to do that here. There's kind of where the capacitor was mounted was right here like this. It had a little clamp that was screwed down to the floor here. So what I plan on doing is getting a couple of terminal strips and drilling a hole, mounting these terminal strips, and then adding these capacitors in here just so that it's all mounted nice. So I think I'll do that now. And then that'll be it for the electrical end of things. The power supply, I still have to replace these two caps. And I'll do that. And then after that I can start reassembling. Haven't touched any switches yet. Haven't done any measuring of contact resistance. I plan to do that. And if the switches are really badly oxidized, I might end up doing some cleaning on them. Or if they don't respond to cleaning, I'll end up replacing them. Okay, so here's what I devised for the capacitor. The original capacitor was mounted like this in here. And then it had the wires going to the top of it. But I'm removing this capacitor, and I'm going to install two terminal strips on the chassis. I have to be careful where I position these holes because they go right into the power transformers right below here. I didn't want to drill into any wires or anything else. So this will go in just like so. I can get this to cooperate. And I got another capacitor here. This one will go beside this one. Just like that. And then I can attach the wires. Both yellow wires will go on this side. And the other 4 wires can go to this side. And get that all wrapped up. I don't need to show you any of those details. But that's my solution. Okay, let me show you something here. I've been going through and doing some testing of these switches. There's 8 of these switches. These are mechanical control switches. They're micro switches. Who they made by, I don't know. Not really sure. But I found this one was bad. It was showing a high contact resistance, so I removed it and cleaned it. And I was checking some of these other ones, and you can see on the meter. Let me connect these up and we'll show you what these show. The center pin is the common, so let's get this. Okay, so that is open circuit right now. Close it, and it goes down to about 18 milliohms, 15, open, closed. So it's staying pretty consistent at around 17 milliohms, which is okay, it's good. I'd rather see it around 10 or 11, but what can you do? So let's try the other side. This should be closed already, and it's showing 12 milliohms. Opening it, closing it, showing about 22, 30 milliohms. That's not the greatest. You see, if you work the switch, that resistance, that contact resistance will come down. Okay, let's try this other switch here. This one here is open, I think. That's closed. Should be closed. Okay, we're getting about 40 milliohms. 60, 50. That's not the greatest either. Let's try the other side. That's 10 milliohms, that's ideal. Let me try this side again. This was awfully high. 70. See, that's no good. That shouldn't be that high. starts off at around 100 milliohms and then it drops. What I'm going to do is I'm going to remove this switch and we're going to clean it. I'll show you what I do. Let me reposition the camera and we'll get in here and we'll show you how I clean these switches. Alright, so let's just remove the switch. Okay. So, pretty easy to open up. You just got to remove the cover, and the cover just snaps in, so you just get a small screwdriver and just loosen the cover on all these three. Okay, give it a little. You be careful, there's pieces in here that can go flying. Just want to be careful. Take it off. Is it working? Okay. All right. Now, switch construction is you got a plunger and it operates on a leaf. And as you push the leaf, it's got a little bit of an oil can thing to it, so it bounces from one side to the other. See, this is what you got to be careful of because this thing wants to pop out. The plunger. Okay. The contacts are silver and they oxidize. So what I do is I get in there with a piece of paper. I just take a little bit of deoxit and just coat the piece of paper. This is just plain old white photocopier paper. And then we just slip it in between the contacts. And just give it a rub. And on the other set of contacts, there's two sets. You see how it comes out black? It's oxidation. Let's put this one here. Comes pretty black. Can't really spray anything into these because spray won't do much. It has to be, you have to get in there and rub the contact clean. Okay, so mainly you don't want to pull these. There's three brass connectors here. You don't want to pull these out and upset the switch. So let's just check its function, still working, and put the lid back on. Snaps on and it's done. Okay. Let's test this one more time here. We were getting 70 some milliohms before. Let's check this side. Yeah, now it's down around 18, 17. Quite a bit of improvement. This really wasn't a good example because when I tested the switch yesterday, it was up around 1 or 2 ohms closed. And that to me is a bad switch because it needs to be less than less than 100 milliohms. But today it's showing a lot less, so, but we cleaned it anyways and it's good. Put it back together, it's showing. Oh, keep clicking it here, it's got different results. Now we're getting 15 ohms. Something's definitely wrong with this switch. Let me take it out. What I'll do is I'll open it up, clean it one more time, and I'll see if it improves. Alrighty, what I did is I took the paper and I cleaned the excess deoxide off there, off the contacts, and now I'm getting consistently 11, 12 milliohms every time I contact these switch. Close the switch contacts, so it's good now. It doesn't like the deoxide, these contacts on these switches, so I'll just put this back together and I'll move on to the next one. Go through and check them all. There's 8 of them. I believe there's 8 switches like this. So check them all, make sure they're all good. Alright, I think it's time to start doing some lubrication here. I'm looking at this grease. All these little slides here, they see with this brass washer. It's like a shoulder washer. Here's another one. There's one here, one here, one here. They're all over the place. Some down here. They have this grease on them, and this grease is pretty much dried up. It's kind of it's almost like a wax now. It's not grease anymore. So I'm going to kind of clean off some of this old grease and then re-lubricate. You see it's everywhere, even here. It's a really thick wax feeling. I think it's just dried up. So I'm going to re-lubricate a lot of this. And then I'll go through and I'll lubricate all these pivot points too, like here, 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 all these different, just to make sure they're all good. I don't think you need to watch me do that. I'll go through and do that next. Okay, I'm just working my way through the mechanicals here. I'm going to work on this Capstone motor. I want to remove it and re-lubricate the bearings. Now, we have, okay, that's exactly what I thought was going to happen. We have shims in here, and these are specific to the screw, so you got to keep these separate. Don't get them mixed up. Remove this. I can take this other one off. And there's 3 shims on that one. Okay, so we got to remember 3 shims on the top one and 2 shims on the bottom one. Okay. You remove the back plate, the brace. This should come right out now. There is a ball bearing here. It's covered in grease, old grease, and that was on the end of the shaft, so you make sure that doesn't go missing. And then we should be able to just remove the rotor assembly. And there it is. Now you got to make sure you clean the dirt off the capstan before you pull this out. Now you got 2 bearings, one here, and one here, and they are pretty much dry. I don't feel any oil on them whatsoever. And then we have a toothed internal gear, which coincides with the toothed pickup coil for the field generator for the servo. And just give everything a good inspection. We've got some nylon or plastic washers in here. So Everything's intact. What I'll do is I'll clean this with some kind of solvent. What can I use? So I'll make sure there's no washers in there that's going to fall out. Okay, so I can clean this with just a small amount of this on a rag. And we can clean this. You see, it's not very dirty. And aside from that, there's really nothing more to do other than just lubricate it and put it back together. And I'm going to use 3-in-1. You don't want to put oil in the hole, because when you push the shaft through, you'll coat the entire shaft with oil. What you want to do is, just hang on, I'll clean this better. You just want to apply it to the bearing surfaces. One here, and the one inside. Not even a whole drop, just a partial drop, and just go back in. There it is. And we need to clean off this old grease on the end. Clean off this ball bearing. Don't lose the ball bearing, whatever you do. Okay. Apply new grease. This will hold the ball bearing in place. It should. And then another touch on the end. And you can see the old grease on here. You can clean this off as well. This old grease has turned brown and it's not doing us any good. Clean that off, put new grease. So what I'm going to do is put the screws in on this back brace. Put both screws in. And then before I tighten it down, I'll add the shims. Just snug it up. And then I'll add the shims here too. Might have to get tweezers to get in behind here. But once I got the shims back in place, I can tighten those down. Okay. Torque those down. That should be it. Considering I reused the same shims, I shouldn't have to re-shim it. And I'll check the backlash on that. Looks like we don't have very much at all. Okay, I'm going to service the reel motors now. So it's just a matter of removing the reel motor stator. This is the outside stator. No, sorry, that's the rotor. My mistake. Stator stays in with the onto the frame. The stator has your windings. The rotor has your magnets. I think it has magnets. I'm not sure. Just loosen these two screws, these two set screws, and we'll just remove the reel table. There is a pulley and a belt, this belt here for the tape counter, so we have to remember to put that back on when we're done. Now it's pretty simple. You just we got one circlip to remove, an E-clip that's holding on the shaft. 3 screws. It's pretty simple. Now I can show you. This cap gets pried out. Let me see if I can get that cap out and get that E-clip. What can I use to hook this? There we go. It's soft aluminum, you gotta be careful with it. There we go. We can straighten that out and tap it back on. It's got a felt washer. It's to capture any oil that gets slung off the bearing. We have our E-clip. And there's a plastic retainer for the E-clip. All right, we can remove the rotor. There's our rotor. There's our stator. There's a bunch of washers here. We got to keep in track. Make sure they stay on the shaft in the correct order. One more, I think. Oh, maybe that one stays. Does it rotate? No, it doesn't rotate. Okay, we're good. You can clean the oil off this, and then we'll put it all back together. I'll clean the bearings out from the old oil, and I'll clean up the shaft of the old oil, and then we'll put it all back together and relubricate it. Okay, when you're done, you need to adjust this. This has to be adjusted so it's proper when you get the motor bolted back in, and you adjust, connect the reel table back together. What you do is you load it up with tape and you start playing it, and you adjust the reel table in or out so that the tape winds in the center of the reel. You'll see it when it starts loading up tape. You can see where if it has to, the reel table has to go out or in, depending on which way you need to move it. That's the only adjustment you do. All right, so we're on the finishing stretch here. Get it back together, put it back, the electronics block back in. Everything was finished with this. Yesterday I cleaned the pots and the switches. Previously it's been recapped, retransistored. So everything's good to go there. Put it back in. And now what I need to do is I need to clean the tape path. I have the head block just loosely mounted in here because I had it apart. I was doing mechanicals underneath. This service manual is awesome. If you're ever working on one, you must have it. It's got to be a must-have. It goes through all the mechanical adjustments, which I did the other day. Yesterday I went through and did all these mechanical adjustments. It's really self-explanatory, has pictures and what needs to be adjusted. Now I'm at the point where I need to do a head adjustment. I can still see it's factory sealed. The original head adjustment was factory done and it hasn't been touched. So I'm really hesitant to touch those unless I absolutely have to. What I'm going to do is I'm going to clean the tape path, load up tapes. I have to adjust the table height on the two reels. And then I am going to do some tests on this to see how it's performing. And then after that, if I don't do anything, if I do or don't do anything regardless, I have to move on to the electrical adjustments, and the manual continues on and gives me all my electrical adjustments for the amplifiers. It's a very good manual, very concise. So it is working good now. The motors have a lot of torque, and I think it's going to work good. Like I said, the next step is cleaning the tape path. Okay, I've been using the deck for about almost 2 hours now, hour and a half, and I'm just letting it warm up. This motor, the take-up motor, is getting quite warm. I'm just doing my thermal cam on it. This motor here, the supply reel, is right about 38 degrees Celsius, and the take-up motor is running around 55 degrees Celsius, quite a bit warmer. But then this is on a higher torque. This is on a low torque in reverse direction, so it's providing back tension. This one here is I think is running under full torque, and then the speed is controlled by the capstan. This heatsink is also getting fairly warm. I think that one's measuring, it's about 46, 47 degrees on that heatsink. We're more concerned about this motor. Let's see here. This motor here is, yeah, it's 56 degrees. And I'm just wondering, if I put it in the cabinet, will it even climb higher? It might climb up to 60. I don't know. The cabinet isn't great for ventilation. Other than that, everything, I'm really pleased with the performance of this deck. It's working great right out of the box right now. I haven't made any adjustments to the head, haven't made any adjustments to the electronics, and it's I'm recording and playing back on the tape monitor at the same time, and I'm really not hearing a difference between the two, between the source and the tape. It's really good quality. I'm just using this this cheap Radio Shack tape here. It says Laboratory Standard Super Tape, but it's working really great, and I'm pleased. The capstan itself is running cool. It is running, it's running at about 35 degrees Celsius. It's warming up a little bit, but everything's working perfect. I think I just might wrap this up and call her a day, because I don't think I can make any more improvements to the sound quality. I still want to get the tape that Angelo supplied, and I want to do a test on that as well. And then maybe what I'll do is I'll make a separate video of a demonstration of a playback, and maybe I'll port it right to the camera, and we can see if we can hear anything that way, and you guys can have a listen to how it sounds. Okay, one thing I'm noticing is that my watt meter, the deck itself, it's on high speed record mode. It's drawing 51 watts, and I'm looking through the service manual. It says power supply and power consumption. All the models, different voltage models, have 90 watts of consumption, except for the Japanese, which is down 65 watts. So I don't know, I'm drawing 51 watts, but the manual says 90. That would be a maximum. I can't imagine what condition this would be in maximum power consumption. Unless I'm doing fast forward rewind. But yeah, it's getting fairly warm. It's 65, no, not 65, it's about 57 degrees now. Let's see here, I've been going for a while. It's almost, like I said, almost 2 hours. And what do we got here for heat on this? Wait for my blur to boot up. Yeah, we're climbing to 58 now. It's getting to the point where you can't put your hand on it. 60 degrees is a point where you can't put your hand on it. It's too hot. 55 is, but it's right around 58 now. Alright, so I was doing some more testing, and it turns out I have a fault somewhere in the left channel. No, the right channel. Yeah, left channel. I'm feeding a signal into the left channel. I have the output turned to the maximum. I have the input turned to maximum. And there's no signal getting through. None. Now I scoped the signal from the input. This is the record board. Yeah, what is going on here? And that's the right channel I'm hearing. This is left channel, it's dead. Right channel. Right channel, left channel. Okay, so, but if I feed in a signal to the right channel, you can hear the right channel flows through, but there's nothing on the left. Doing some voltage measurements around these transistors here, and I have the voltage measurements here, and they're not matching. I'm getting some weird results. I think I might have an open resistor, or yeah, I don't know. It's completely dead. So I'm going to keep poking around here until I find what's wrong with this. I thought there was something wrong when I did my test recording. It seemed like this potentiometer didn't work at all, and this one was the only one that was setting the signal. That's noise from the microphone amplifier. But I had a feeling it was feeding both channels. Maybe it was recording both channels. This is the tape monitor switch is working fine. I checked that because the signal does depart here, goes to the tape monitor switch, and then enters back here, and then it goes into this first transistor, and this first transistor has no power to it. Try and determine why it's got no power. This whole side is dead. Maybe I got an open resistor. I do have 24 volts on the bus here. This wire, this trace is 24 volts. Ground is there. So I'm wondering if I have an open resistor somewhere here. I put brand new transistors in, so it shouldn't be that. And I did test them with the diode checker. They're all testing fine. Okay, I believe I found the problem. It looked like it was a solder bridge on one of the transistors I installed. It was even after I cleaned the board and inspected it with a magnifying glass. It looked like a little blob of rosin flux, and when I started picking at it, it was hard, like metal. But I think it's gone now. Okay, so I'm going to reinstall this and try it out again. What did that screw me? About 2 hours of screwing around trying to find that problem, but hopefully I got it fixed. Okay, let's put this back together now. Alright, so I removed the short on the emitter to collector junction on the printed circuit board. I couldn't even see it. I had to actually scrape it with a screwdriver before it revealed itself. But that's gone, and I have my channel back on left. But then I had another problem, and that was operator error on my part. It was a big no-no, but it didn't occur to me until after a while. What I was getting was feed from one channel into the other, and I couldn't figure out why. For example, here I'll show you. I'll turn on the left channel. You can see it up on the scope there. And it was bleeding through to the right channel. I couldn't, what the hell? And I'm looking at the schematic and there's no connection between the two. Even on the boards, they're completely separate from each other, the right channel and the left channel. They're right down the middle, there's a division line. I couldn't figure out what was going on. And then I had turned up the right channel, I was getting feeding into the left channel. And I was like, what the hell's going on here? What it turned out to be was my cheap little amplifier. I had the mono button pressed in, and the last time I used it, I was using this as a mono amplifier. And what that did is that backfed the signal from one channel to the other. So if I turn up the left now, for example, I get signal on both channels. One of them is attenuated a bit, and here's the right channel. But if I, yeah, my mistake, I had that button pressed in. So now we got both channels working. Everything seems fine, everything's scoped out perfect. I'm going to reassemble this and then we'll do our final tests now, because wow, that was a head scratcher, and that one really threw me. Just thinking pressing a little button in like that and forgetting about it caused a lot of mayhem. Okay, so here's a look at the components I've changed. I'll just dump them out here. So what we have is 16 transistors. These are 2SC 458s. These were problematic, and I'm willing to bet there is at least 2 of these that have gone bad in the circuit, because I was hearing noise on both the record amplifiers and the playback amplifiers. Now that I've changed all these 16, I don't hear any noise. It's completely silent now. Well, there's still background noise, but it's not as bad as it was before. It was really prominent, and you could hear it. So that's done, and everything's good there. 66 electrolytics. Probably I replaced 98% of them. I left a few because they were testing just perfect, so I left them alone. And they weren't in critical circuits. These are mostly the electrolytics that were in the amplifiers, the playback record amplifiers. And some of these yellow ones, these are like 1970s version of audio grade. That's what these are. And these were testing pretty weak. I actually never found a failed capacitor in this thing, but I did find a lot of weak ones and a lot of high ESR ones. The Sanyo cap, that's kind of a lone wolf. I always replace these regardless because they have a history of going bad, so they all got changed. These 2 capacitors are, I think they're kind of like a non-polarized electrolytic. I should actually rip one of these open and see what's inside. Date code 1977, 12th month. One tested fine, one tested open. So these were in the circuit for the 2 real motors, and it was in the power supply feed for the real motors. And I don't know what effect they had on the motor operation, other than they were more like a suppression cap to keep the transients down and keep the noise down on the power lines. So that was done. I also replaced this electrolytic. I'm assuming it's electrolytic. It's in an electrolytic can. It's a 3+3 microfarad. It's a dual cap. This one's date marked 1978, so that's probably an early 1978, late 1977. Replaced it with a film capacitor of 3.3 microfarads, and this capacitor is for the induction motors, the eddy current induction motors, and it seems to properly work now on rewind and fast forward. As before, it was kind of stalling out at the end of the reel. As it got close to the end, the motors kind of lost oomph and torque, and everything slowed down. But now it seems to go right to the end, no problem, and works. So that's a success there. And that's about it for this everything else was good. The bulbs were good. Potentiometers cleaned up nice. Everything else is untouched and original. So what I have here, I'm feeding it a steady 1000 hertz tone. You can hear it. What I'm going to do is I have this meter set to plus 3 dB on both channels, and I'm just going to increase the frequency of the tone generator, frequency generator, and I'm going to see how flat it is. We're going to start going up here until we get 3 dB down from where we originally started. I'm just going to keep going. I would say right about there. And I'm measuring 29 kilohertz. So that's the frequency response of the record amplifier. Let's do the bottom end as well. Let's go over this way. 10 hertz, 20 hertz. Okay, so we're at 40 hertz there. It's a little bit high. Actually, let's go here and turn this down until we get 3 dB down, and we are at 30 hertz. So typically responses from 30 hertz to 29 kilohertz, and that's just the frequency response of the amplifier itself. All right, for the next few tests, I loaded the tape, and this is the tape that Angelo supplied for me. It's an ATR Magnetics MDS 36 referring to probably, I'm guessing, 3,600 feet long. No, it's 1,800 feet long, sorry. But it's a nice quality tape, no doubt about that. So let's set this up to record tones, and let's feed it. Sorry. Let's feed it plus 3 dB on both channels, which is already set up here. And we'll use that for our reference as an input signal, and then we'll monitor what comes back on the tape. So let's start. And we're getting back about plus 4 dB. And it's pretty steady, pretty rock steady. I don't know if you can see the meters pretty good. Let me zoom in on the meters. Good view of the meters so we can see what we're going to do here. I'm going to use the meters as my reference. They seemed accurate enough on the first few tests, so we're going through with it. So we got it at 1000 hertz now. Let's increase this slowly. The rate channel is holding up pretty good. It's at 10 kilohertz right now. We're at 15 kilohertz, still holding. That left channel is struggling a little. 16, 17, 18, 19, 20 kilohertz, 21, 22, 23, 24, 25, 26. Now we're starting to create harmonics. 26 kilohertz. This is beyond the frequency response of the tape machine. It's not intended to work in this area. 27, 28, 29, 30 pretty much drops to nothing. That's pretty darn good for, you know, a 45-year-old reel-to-reel. Okay. So what I think I might do is I might try tweaking the head to see if I can bring back that left channel. It seems like it's not quite tracking properly. Kind of concerned. I don't think there's any mechanical problems. I think it's just an alignment issue. So let me try getting that straightened out. Okay, so I've got the head alignment screws here. There's 3 screws here on this side. This is the reverse playback head. 3 screws here is the forward playback head. So I'll be adjusting these screws. This screw here and this screw here adjust the azimuths for both heads. These 3 screws adjust the erase head in the center. So I should only actually need to touch this screw here to get it to behave properly. So we got it all set up, and let's start with the tape. We are feeding at 1000 hertz tone. Let's go up in frequency again until the left channel drops. Where are we here? I'm at 17 kilohertz right now, 18. Let's see if we can do this at 18 kilohertz and if we can get these meters to go equal. Might not be able to do this. I got a mark here. I left a mark on the screw so that I can return it back to the original position, but let's just try cracking this. Maybe get a better screwdriver. No, that one's magnetized. I don't want to do that. Just crack this. And let's just try adjusting it back and forth around that point. Okay, we're losing it on there. We're losing it right there. So we've got to set it for the center. And that's about as good as it's going to get. And that was originally the original position. So, what do we do next? Let's see here. That might be as good as it can get. We don't know yet. But let's try the other two screws. One is the height adjustment for the front. One is the height adjustment for the back. So let's try the front one first. And again, I got it marked. Let's crack the paint. It's going down that way. Going down that way. So it was peaked right at that spot. It was peaked right at that spot. Okay. Let's try the back. I don't think this will have any bearing on what we're getting, what we're looking for, but let's try it anyway. Okay. No. There's no improving that left channel. It seems it could be. Let me try this one more time. You got to remember, we're at 17 kilohertz. That's pretty darn good for a tape deck. This, yeah, it is not going to improve. All right, so maybe what I'll do is I'll reseal these with paint, and then we'll go on to the reverse tracks and look at that as well. So I tried setting this up to record in reverse direction, and I guess the tape deck won't allow you to record in reverse direction. You have to flip the reels over. I went through the manual, and it didn't say anything about recording in reverse direction. It's, but it can play back in reverse, so I have to flip the tapes around. And this is the signal that I recorded with the forward playback heads, forward record playback heads, and now we're doing it with the reverse. We're listening to it, and it's got good volume, good levels. And I'm going to wait till it gets up to that part where I was doing the adjustment with 18 kilohertz, and we'll see how this looks. I expect it to be pretty good. It's looking pretty good right now. It's not much of a change. Here we go. I think that was around 10 kilohertz, and then it keeps going. It stops at 18. So this head is playing, yeah, I think I went beyond 18. I kept going up in frequency up to 30 kilohertz. I'm just getting harmonics. Okay. Okay, here we go up to 18 kilohertz. We can see we're getting a little bit of bias bleed through and harmonics, some beat signals is what we're hearing. This side is doing a lot better, I think, than the other direction. I think it's picking up a little stronger signal. I might be wrong on that, but I'm not going to touch this side. I don't think it needs any adjustment whatsoever, so I'm just going to leave this alone. And I'm going to go back and clean this head one more time. I don't know, maybe that head is dirty, maybe that's why it's not performing, but I'll try it one more time with the head cleaning. Okay, we're going to do one more record test. I got it set up in record mode, paused. I did adjust the azimuth and the height of the head. Didn't seem to make any improvements. So the next thing I'm going to try is adjusting this post. And that post controls where the tape is located on the head. And maybe this was a little bit out. So I'm going to adjust this same 18 kilohertz tone. I'm feeding it 18 kilohertz on the input. So let's turn this on, start recording. And then switch it to the tape to monitor what's coming back from the tape heads. And we can see we are down about 3 or 4 dB on the left channel. So let's try tweaking this adjustment nut and see if this will make any difference. And I hope you can see this. Okay, so let's go one way. Let's try this first. Okay, we're going down both channels. Let's take it the other way. I think there is no improvement in this adjustment either. I don't think I'm right actually at the sweet spot right now. So I'm just going to go back and forth. And it's dropping there. Go back this way. Peaks right about there and starts to drop. So I'm going to leave it right where it was. I'm not going to adjust that again anymore. I'm going to lock all those adjustments in place, and that's as good as it's going to get for today. 18 kilohertz is pretty good. It's a pretty good signal for 18 kilohertz on a tape machine. That's impressive. So what I was doing is I was erasing the tape and of the test tones that I made. And I was queuing it up to do a sample recording of a musical track, and went and had lunch and had it just sitting here. And came back, it was turned on, but look what happened. Turn it to the source. I don't know if you can hear that. That's coming from the source amplifiers, so that it would be the record amplifiers. That's the left channel. That sounds like a bad transistor, but I just replaced the transistor, so yeah, I'm kind of scratching my head here. I'm going to have to go in and finish diagnosis again. Not really sure what's going on here. Let me put this on pause, put this on play. Tape is blank. Here's the playback from the tape. That sounds normal. Source. Here is the right channel microphone, left channel microphone. They're not quite equal. This is the line input. There's nothing connected to the line input right now. It's completely disconnected. So there's something internal that's making that noise, and it's in the record amplifier. So I'm going to have to go and probably try and scope this to find out what's going on. The output amplifier playback is quiet. When I flick it to tape, this is the playback amplifier working. Yeah, I can kind of still hear it on the left channel. Maybe there's something in the power supply. Definitely can hear it in the source. Okay, back to the drawing board. Okay, I'm actually kind of glad it started doing this now rather than after I boxed it up, shipped it back to California, and the owner hears this. This is embarrassing. This is after going through these boards like that. Wow, really getting angry. Let me turn this down. After going through these boards like that, replacing all the capacitors and all the suspect transistors, you shouldn't be hearing this. I kind of thought it might be a power supply, dirty power supply, but dirty power supply would affect both channels. And let me show you. I'll put it on. That's the right channel. It's got hiss, but it's not making that awful noise. And this is the left channel. Here's the input for the right. Line level, mic level. A little bit scratchy there. I didn't do a very good job. Go to the left channel. Mic level, line. So I don't think it's in the microphone amplifier. If I switch the tape monitor switch from tape to source, it goes away, right? Or does it? Can we still hear it? Not really. So that tells me it's not a power supply problem. It's got to be something here. So we got it on left channel. You know, that circuitry is active. This is the playback amplifier and line output amplifier. So let me see here. I got my scope hooked up. Let me try scoping the power. Flexing the board does nothing that I can see. I'm wondering if it's one of these potentiometers that have gone dirty. That's a coil. Let's see here. That's the left channel. Here it is. This one's frozen. It might be that potentiometer, that adjustment. Try this again. I have a sneaky suspicion that might be the problem. Let me see if I can get some cold spray on it. Where is my cold spray? Oh, there it is. Okay, let me see if I can get some cold spray on this and if it'll affect it or change it at all. It doesn't seem to affect it at all. I'm just going to go through and scope some of these transistors and see if I can figure out I can see it on the screen. Let me set a camera up and I'll show you. Alright, got a scope set up, you can see it there. Let me scope some of these transistors. This transistor here is definitely screwed up. Okay, let's go on to the next one. That one's not. Okay, that one's got the signal on it too. Keep going. And I touched something here and it stopped. Right here on this transistor. Let me shut the power off and have a look at that. There's no shorts. That is really odd. Just going to apply a little heat. Just going to apply a little heat to the board. It seemed to make it wake up. Seem to make it want to start, so I'll just apply some general heat. I'm only giving it about 100 degrees Celsius, so it's just warming it up. Now it stopped. There's no crack solders, there's no shorts. I don't understand why it would do that, unless they got a bad resistor in here. That was the same noise it was making before I started the work. And it's possible there's a bad resistor in here that's gone open, or is going open with age. But you would think that any kind of mechanical flexing, it would come back and come and go. And nothing here. Alright, now that it's gone away, I can't get it to come back and recreate that fault. I did resolder one resistor lead here, this one right here. It looked like it was kind of dry, but I don't think that was it. Something is not, it doesn't seem mechanical, like a mechanical broken joint or anything. But I'm just going to leave this on for a few hours and I'll see if the noise comes back. I hope it does. I hope it does, and then I can track it down, because I don't think I tracked it down yet. I think I was in the right area, but with the scope I could trace the noise on these few transistors here, but I couldn't pinpoint where it was coming from. I might have to change these transistors out again. Maybe I got a defective one in there. I don't think so. They're quality transistors, purchased them from a reliable source, so it's possible it's bad, but that noise was there before too. So that's why I have a feeling it's something else other than a transistor. Could be a bad capacitor, could be a bad resistor. I'll just let it go for a while and see if it comes back. Alright, so I've left this thing on for 2 hours and it hasn't come back. But I can still hear the noise. It's still there, but it's very, very quiet and it's very muted now. I can hear it. If you listen really carefully, you can sometimes hear it kicking back on. And it's, but I'm also taking a plastic stick and I'm going around poking at different components. And some of these resistors here are microphonic. And I'm just thinking maybe this is one of the problems. Like, for example, if I tap some of these resistors, I can hear it in the speaker. Like this one here. That's in the high gain stages. And back here, I think I have either a bad capacitor or a bad resistor, but it's not revealing itself to me here. So I think I might tap around, and any resistors that make any kind of microphonics, I'm going to mark them, and I think I might just pull them out and replace them, because resistors shouldn't be microphonic. I think I have a failed resistor here somewhere. I think it's this one back. Where is it? I wish the noise would come back and I could troubleshoot it better, but the last thing I want to do is put this thing back together, send it back to the owner, and then have it do it again. Oh. Right there, what's that? It's a resistor there. That one's really sensitive. What transistor is that? That's a capacitor. Capacitor shouldn't be microphonic. Now it's not microphonic. What's going on? And that is capacitor C11. C11 and R24. This one here is really loud. What is this one? This one here is R17? No. I need a flashlight. something wrong with this area of the board here where all the parts I touch are microphonic. So I'm wondering if I have a bad joint. But poking the parts does not reveal anything. That resistor there is a 68K. Let me write some of this down. Alright, I sprayed that area with some cold spray, and it's starting to act up now. You can hear it. It's coming back. Now I hope that's not just the moisture on the board. There's definitely a bad part in here, because listen to it when I spray it. You hear that? That's all through the speaker. That's coming through the speaker. Doesn't matter where I spray on this board, it just makes that noise. So I'm going to pull out some of those parts and start replacing them. Maybe make this go away. Now that it's starting to reveal itself, I think I know where it is, and I got it located down to about 3 or 4 different parts. And if it comes right down to it, I'll just replace all of them. And yeah, listen to that. There she goes. My pokey stick. This capacitor right here. I think I found it. Yeah, it's a capacitor. It's let's see here, what's C14? It's 22 picofarad. That's a bad one. Okay, let's change that. Alright, I replaced the capacitor. It's a little tiny ceramic. Okay, I tested this little capacitor. It tests fine. There's a little ceramic disc. 22 picofarad. Turn it back on. I still seem to have a noise. Poke around here a little bit more. I might be starting to change some resistors. So I removed 3 resistors and replaced them. Now I've had this on for about 2 hours this morning. It's cranked up full volume. Everything's, and I'm getting complete silence. I'm not getting that noise, that rushing noise, that distortion. It's completely gone as far as I can tell. I can't hear it. Alright, I've had this on, this is the next day, and I've had this on for about 3-4 hours now. Yeah, getting close to 4 hours, and it hasn't made that noise anymore. What I did yesterday is I replaced 3 resistors, 3 little small resistors, and I replaced a 22 picofarad capacitor. I don't know if my changes helped, but it's gone now, and I can't recreate the fault, so I'm assuming it's gone. I poked and prodded on this thing for a long time, and I can't get it to come back, that noise. So what you're hearing now is maximum gain on my amplifier, maximum gain on the output, maximum gain on the input, and we're hearing essentially noise, just transistor noise, circuit noise, and you can hear it. It's quite stable, and it's steady, and it's not fluctuating like it was before, and it's not rumbling and hissing and popping, but that is normal background noise. So what I'm going to do at this point, I'm going to put it all back together. I'm going to do my final recording test, and then we'll close this up.